Hello and welcome to the 2.7 notes. This is a section about inverse functions. So when we talk about inverse functions, what that means is that we switch, x and y and solve for x, okay, or solve for y, I mean, okay? So whenever you see inverse functions, this is the idea. Okay, we switch x and y and solve for y. And so let's just think of, a generic function here, and I'm going to zoom in pretty far. Okay, let's just think of the function, say f of x is equal to, say, 4x plus 7. Okay. What I want to first do is rewrite this using y equals 4x plus 7. Okay, and then I'm going to switch x and y. Okay, and I'm going to rewrite this as x equals 4y plus 7. And then I'm going to solve for y. So I'm going to subtract 7 from both sides. Okay, and I end up getting the equation x minus 7 is equal to 4y. I'm going to divide everything by 4, okay, and then I'm going to get y equals 1/4 x minus 7/4, okay, and this is my inverse, all right? And so when I have that inverse, okay, I'm going to rewrite this as f inverse of x is equal to 1/4 x minus 7/4. Okay, and when I write f to the negative 1 power, this notation here means that I'm talking about the inverse function of my function f here. Okay. So that's one thing we can do. Now, what I notice here, this is a linear function, okay? This is going to represent a line. In this function, okay, this is also a function, okay? F inverse of x is equal to 1/4 x minus 7/4. Okay, and what I would do is I would kind of graph this, all right, to determine whether it is a function or not. Now, let's look at something else, all right? Let's look at another example. Okay, let's look at, say, something like this. G of x is equal to x squared. Okay, now this function, let me rewrite this as y equals x squared. All right, and then what I want to do here is switch x and y. So switch x and y. So x is equal to y squared. Now, if I wanted to solve for y in this case, I would take the square root of both sides. Okay, and I would end up getting that y is equal to plus or minus the square root of x. Okay, now here's the issue. This is not a function. Okay, and here's why. If I graph, you have two different equations here. Here you've got y equals plus the positive square root of x, and you've got y equals negative square root of x. Okay. And when I've got that, I've got two different graphs here. Okay, when I do the positive square root of x, okay, that graph looks like this. Okay, when I have the negative square root of x, that graph goes down like that. Okay, and what I have here is a sideways parabola. Okay, now let's think about something for a second. If I talk about my original function, y equals x squared, that graph looks like this. Okay, whoops. And I have a parabola like that. Okay, and what I know about this is that these are reflected over the line y equals x. Over y equals x. Okay, and that's just pretty standard, just the definition of what an inverse is. Now, one way that I can tell if a function, if a function's inverse is a function, okay, so, what I see here is that if I look at this graph here, I've got, this is a function, my parabola. All right, and what I know is this passes the vertical line test. And so if I have a vertical line here, what I notice is that if I move that line over, it's only going to hit that function at one point, okay? And so this is a function. Now what I can also tell, I do the same thing for my inverse on the red graph, okay? What I notice here is that this graph touches the vertical line at two different spots, okay? Therefore, my inverse is not a function, okay? Now, what I can do is do what's called the horizontal line test. And what the horizontal line test does is that if I do that on my function, okay, if my original function doesn't pass the horizontal line test, then my inverse is not a function. All right, now let's look at that original one that we just did. Okay, if we've got 4x plus 7, let me just quickly draw a graph of that. So here's the graph, 4x plus 7. That's a graph that looks like this. And then 1/4 x minus 7/4 looks like this-ish, okay? And, this is reflected over the line y equals x, all right? It's not the best graph, but it'll do. But what I know is, if I take my horizontal line here, okay, my original function here passes the horizontal line test. Therefore, my inverse of this is also a function, okay? And I can even test that and do the vertical line test to test and see if that's true, okay? So, kind of a lot of information in a little short amount of space, but do your best, and we'll talk to you soon. Thanks a lot. Bye.